Okay, let's go over homework 3.3, number 10. Alright, so we're going to use a graphing calculator to solve this problem. Right, so first thing is that you have an ordinary annuity consisting of quarterly payments. Alright, so we have a payments is given right here. Right, so that's our PMT. Right, so maybe I'll circle this. And you have a 3% right here. So that's going to be our R, right? And a compounded quarterly, that means that M equals 4, right? Worth more than a principal. So this is going to be our P. Then interest rate 7%. So that's going to be our R. It's a different from this R right here. Right, so let's look at the annuity one. So it's going to be a future value is going to be, remember that the formula is payment times quantity 1 plus I to the nth power minus 1 over I, right? So we have to do a little bit of calculation. So I, in this case, I is always R divided by M. So R in this case 3%, so it's a 0.03% over 4, which comes out to be 0.0075, right? All right, then also we have to come up with N. N is simply M times T. So in this case, 4T. Right? So put everything in. We're gonna get, so PMT is 637.73. Got that. Then I is 0.0075. So 1 plus 0.0075 would be 1.0075. Raise it to the n is 40, so raise it to the 40 power. Then subtract 1, then divide it by 0.0075. Right? That's our future value for the annuity. And let's see, the other one is a simple interest one. So the future value A is going to be principal, which is going to be P, and times quantity 1 plus RT. So if you plug everything in, so P is 4,300, right? Then quantity 1 plus R is 0.07, because for that one it's a 7% simple interest, and times T. All right, so let's type those functions in. Only difference is we're going to have to use X instead of T in a graphing calculator. So go to a graphing calculator, right? So go to Y equals. All right, so first one is 637.73 times, so left parenthesis, and a 1.0075, raise it to the 4 times x power, right? Then minus 1, so minus 1, then right parenthesis, then divide the whole thing by 0.0075, right? So that's the first function. Then for the simple interest, we have 4,300 left parenthesis and a 1 plus 0.07 x, right? So we have that, and let's see, make sure that I have the correct one for the top one too, and just to make sure that I put x there. All right, yep, I put x there. All right, so then we have to put the window size, and I'm gonna set x min 0 and x max around 5. 5 years is probably good enough to catch up to simple interest, and x scale is 1, y min is 0, and I'll just make sure that they're big enough, so I'll put 10,000 for y max so that we can see the intersection. And that's that. So let's hit graph. So push that button. All right, so that's probably the annuity one, and the second one is the simple interest one. All right, so we want to see when the annuity catches up the simple interest here. So I'm trying to find the intersection. So I'm going to use second trace, so that's a calc function. Then number 5 is the intersect, so we click on number 5, right? So first curve, you said hit enter, yes. Second curve, yes. And then you don't have to move it, you can just hit yes by hitting the enter. All right, so you can see that the intersection here is 0.85, so we want to make it correct to the 1 decimal place. So it's going to be 1.9 years, right? So let's put that in. So it's 1.9 years. All right, that's it. I hope that this was clear.